All right, good afternoon, everyone. Thank you so much for attending Day for Data today. We're very excited to welcome you to our panel discussion on consulting and defense. We have a very exciting discussion planned for you today, and we are going to be focusing mainly on the impacts of AI in the defense industry. So before we get into everything, we're going to go ahead and introduce our panel today. So welcome, everyone. My name is Dee Black. I'm a senior consultant with EY. I've been with them for 5 years now, a double Hokie. Actually graduated here with my degree in hospitality and then came back for the MSBA BA program. And right now I'm working with DoD clients focusing on audit readiness, doing audit analytics and financial reconciliations. So I'll pass it off to Michael to go ahead and introduce yourself.
Thank you. My name is Mike Brennan. I'm the Chief Operating Officer of Node.Digital, a small 8A business based up in the DC area, focused on intelligent automation and AI ML solutions for both federal and commercial clients. On the federal side, mostly DoD, Customs and Immigration, and IRS. On the commercial side, Porsche and Estee Lauder, so a little difference. Yeah, right. Kind of fun, kind of different. Let's see. Most of my background is in the DoD space, so my use case for one of our discussions will take place in that environment. And I'll leave it with my daughter is a senior at Tech and a captain of the cheer team, so sometimes I get to see her on TV, so that's kind of fun. So, over to you.
Thanks, Michael. I'm Keith Johnson. I am with Amazon Web Services. I currently lead the solution architecture team that supports the U.S. Department of Defense. Prior time with Lockheed Martin and Leidos defense contractors going back for quite a few years. I had a daughter that graduated here from 2 years ago, so, and I have a master's degree from Virginia Tech.
Wes Lawson, currently VP of Contract Research at Leidos with our national security sector. Prior to that, a number of years of experience kind of delivering capability to DoD and IC, and then also performing and executing either independent or other contract research across a multitude of areas in the community. Virginia Tech grad, double E from quite some time ago now, but yeah, good to be back.
So as you can see here, we have quite an esteemed panel ready to discuss consulting and defense. So starting us off, there's a significant belief that AI technologies, and therefore by definition, analytics and automation, will exponentially transform how work is performed and the pace of execution across industries throughout the world. There are massive expectations for AI, analytics, and automation to advance the mission. And not only expectations, but there's also a massive spend on AI unfolding. So it's projected that by 2026, the global AI spend is said to be $300 billion. The US federal government specifically is projected to spend $12 to $15 billion on AI alone out of their overall IT budget of $125 billion. When we recognize that typically 75% of IT budgets are spent on just keeping the lights on, maintaining steady state operations of existing infrastructure and systems, that means that AI and analytics and automation, that represents a significant projected spend on the innovative solutions. And for these reasons and others, we're fortunate to have this panel of industry experts here with us to shed light on the adoption of generative AI, analytics, and automation to enable the government mission. So this brings us to our first question, which I'm going to direct to you, Michael. Okay. How are federal agencies currently utilizing generative AI technologies, and what challenges have they encountered during implementation?
Okay. So that's an impossible question. So obviously across the federal government, there is a great disparity in terms of, on a variety of fronts. Technical sophistication, you name it. And the orientation of their missions is so different that Gen AI has a role in some areas and very much less in others. So there's the mission-focused side of the world. There's more of the back office, side of the world. So it's variable. I'll invite each of my colleagues after I sort of talk to see, they were going to have their own examples. But I thought I would just explain one that we're working right now with OSD and just show you sort of the state of the art, at least in this particular part of OSD, in terms of the challenges that we're facing, the potential benefits, and sort of how it fits into the different workflows. I think that's really important. You can talk about Gen AI from just a pure standpoint, but when you see it sort of inserted into existing workflows, it crystallizes a lot of things, I think. So my example is we're working for OSD R&E right now. Specifically, we're discussing with the Raider program. So it's the Rapid Defense Experimentation Reserve, both head nods over here, right? So if you think about an OSD office with about $1 billion budget, and their job is to basically take new concepts and ideas and quickly evaluate them on a variety of fronts. If they pass certain stage gates, get them into prototyping and experimentation, and get them out into the field as quickly as possible. So DARPA does the long-range vision. OSD, the Raider program, is all about fielding things to our services as quickly as possible. So how do they do that? $1 billion, lots of ideas come through. Those ideas come from those services. They may come from vendors. The first thing they've got to do is do basically some PhD level technical analysis very quickly to say, okay, is this a viable concept? Some of these ideas are very advanced, and so the level of scrutiny is difficult. It takes time. They also need to look across other past research environments to see, has this been done before? Is someone just trying to give me the same thing over and over again? So we got to watch out for that. So it passes some of those levels. It then goes on to a more deep military utility assessments, modeling and simulation, .mil PF analyses, doctrine, training, logistics. Okay. And all that takes time and produces a volume of information for all of this. At the end, they need to synthesize the hundreds to thousands of pages per technology down to a small consumable amount for the tank, for the DoD leadership to basically say, okay, we're going to invest in these areas. $1 billion goes pretty quick, actually. So, so we're working with them to create basically a Gen AI-based knowledge base. You know, the first part would, when a new idea comes in, right now there's a PhD level tech or many who evaluate the capability. Gen AI holds the promise to very quickly look across the corpus of past research and identify, is this truly unique? Have there been other studies and analyses and research that's been done before or not? Right. So that drastically reduces the time, and it's more comprehensive. They can look across, the Gen AI capabilities can look across a very wide array of technology. If that passes, then most important part would probably be the next one, which is how far away from our current capabilities is this technology in terms of doctrine, training, logistics? Can we field this? Do we have to retrain everybody to use this technology? So there's a lot of things that the Gen AI capability can suss out very quickly in terms of how far is this and how much money is this going to take. Lastly, we synthesize a lot of the information from the M&S models, from the utility assessments, and crunch that down to a bite-sized component that the leadership can basically choose and read and evaluate. So some significant benefits. One of the other benefits, it provides folks who come into the OSD office who may only rotate for a year or two or three, the ability to query and understand the corpus of research that's happened before and to query it to their heart's content so they can come up to speed much quicker. So a lot of really interesting additions, time, comprehensiveness, knowledge retention, right? Now you said the limitations or the challenges. Wrangling the data is really, really hard, right? So the data ops that supports this is not trivial. The data use agreements, you think they'd all play nice? They don't. The services don't always play nice. So the data use agreements to get access to the previous research is really important, right? And then where to house the environment. So the more you consolidate in the defense landscape, the more you put together, the more it becomes a classified issue. And so we were having a talk about this before, which is at what point and where do you house the Gen AI capability? So that is ongoing right now. So that's, you know, it may not be the most sexy, but it's really impactful and hopefully touched on a couple important things. So I'll turn it over to my colleagues.
Hopefully house it in AWS. A couple other things I'll throw out around AI in defense in particular. One is going over a lot of different data sources. We have something called, in the intelligence community, called the PED process, exploitation, and disseminate. Lots of different data sources, thinking like satellite imagery for one. And so there has been major programs stood up to automate the analysis of overhead imagery. The MAVEN program is one in particular you've seen in the news, which has resulted in lots of great activities, and can't go into details, obviously, but suffice it to say, it's still going because it's still serving the mission very, very well. That's housed in AWS, by the way. Another area that is really interesting is digital engineering, and so thinking about how you could take AI in the digital engineering. So as we're building new platforms, autonomy in particular, in like autonomous drones or other vessels, taking Gen AI and you can explore more of the design space very quickly with generative AI techniques, and you can rapidly iterate across, like going from design, going through computational fluid dynamics evaluations, understand key performance parameters like drag or whatever, and then pick the best one and then go back and then use Gen AI to recreate the next iteration. You can do that a lot faster with AI now. And a third area, just throwing out there, is as we're looking to obviously use more of the data, pull more data in to do like tracking of both blue forces and red forces. How do you know where they're going to be in the future? How do you do predictive? So we're pretty close to solving the fusion problem of how do I fuse different signals data together to know where something is. The question is, where is it going to go, right? And so we're using AI techniques now based on lots of historical patterns that we've seen, that we've witnessed, to provide operators a much better idea about where things might be going in the future, and that helps provide better courses of action that we can then recommend for what we should be taking for when we see certain activities happen. Those are a couple of things I just want to throw out there, but suffice to say that there's a lot going on and it's really exciting.
Yeah, I know we're probably short on time with this question, but one last thing to wrap this up, to kind of just pull the thread on what Keith was mentioning, we have kind of historically, right, we've had like Kalman filtering and what have you for projection of forward location for ballistic missiles, right? Yeah. Or like Keplerian dynamics, right, for movement of things in space. Those are things that are pretty easy to project. But trying to predict the movement of a social populace or of a thought or of a society, or even like a group on a battlefield might even be a little bit easier, but being able to project where it is, or where it's headed, and what impact they're looking to achieve, I think there's great power in some of these.
Especially with autonomy. Like how do you deal with all that?
That's exactly, and how do you manage all of that? I think there's great power in this, and we're still some way from figuring that out.
So adding on to that, something that's top of mind for a lot of people right now is the responsible and ethical use of AI. So how is the federal government preparing to regulate and govern the use of AI, particularly as these technologies become more autonomous and integrated into critical operations? Are there federal AI frameworks, regulations, and policies to guide the implementation and use of this technology? Or is this left to the discrepancy of each agency and program? And Wes, will have you take this one.
Yeah, sure. I'll leave some time here for my colleagues to discuss, because they have great insight here as well. I think the simple answer to your question is actually yes, right? In that it's all of that. It is a bit of a Wild West, but there are also frameworks and methodologies in place. I think if you just kind of take a look at DoD kind of writ large and look at what CDAO is trying to do for DoD.
You want to explain what the CDAO is?
Yeah,
kind
of acronym city here, isn't it? Yeah. So CDAO is essentially the defense organization that's responsible for kind of AI adoption, governance, et cetera, across all of DoD, and everything from some relatively simple use cases to more of the kind of abstract kind of approaches for how they need to be thinking about AI and driving those models forward. But they have, I'll give an example. They have a toolkit. It's called the RAI toolkit, the Responsible AI toolkit. That is a framework of tools, right, that they would like organizations inside DoD to adopt, right, so that they can actually have some level of approach of being able to say that we are being responsible with the data or with these applications of AI. And I think for the most part inside, whether it's DoD or the IC, when we kind of talk about narrowly focused AI or kind of focused on automation of specific techniques or specific data sets, I would say that's been in place for a number of years, and there is a fair amount of comfort with the application and use cases of those. But when we start thinking more about the big push, right, that brought everybody's awareness to AI, which is ChatGPT and OpenAI and all of the large language models, right, that have really come public here in the last couple of years, they're And you heard a little bit of reference to it here earlier, right? About kind of where do you host those things, and how do you trust that they're actually going to stay where they are supposed to?
You can trust AWS.
I should have known that that's how this is going to go. And by the way, Keith and I have known each other for years, so there's going to be some of this banter. I think when you look at the large language models, there is a little less regulation there. And some of it is a lot of the organizations don't really know yet how to trust it, if they should trust it, where it should go, and what they should unleash it on, right? Like there are a couple use cases that I'm aware of. I'm sure some others here knows much more than me, but like the application, the generative AI and large language models to actually support automated translation and translation on specific topics, even in like low resource languages. So for example, like Russian, Chinese, Spanish, et cetera, those are considered kind of high resource languages. But we found in some cases that large language models are actually quite effective at low resource, like African dialects. And they can do that with relatively strong BLEU scores. So those are things we didn't think about, and those are hard problems. So if we can keep like large language models focused on those, there's going to be probably more and more adoption. But I will say in general, they want to adopt, but there's still the apprehension of exactly how to do that.
I'll just highlight, and we talked about this earlier, the White House issued the National Security Memorandum for AI that came out October 24th, so just about a week and a half ago. In there, I think there's basically 3 activities. One is ensuring that the U.S. maintains leadership in AI from a national security perspective. The second one was around establishing AI governance and frameworks to ensure that we are handling and deploying AI correctly. The third had to do with international collaboration in that space as well. But it does direct, and I haven't gotten to the weeds, but it does direct every agency that's employing AI to have a specific governance framework, and it needs to be evaluated against a couple of factors, including ethical. Is it implementing ethical charting bias and things like that. So there is now a top-down approach that has been issued, and that will be every agency will have to report back to the White House how they're implementing that. It gives, I believe it is CDAO for the DoD at least, and other agencies as the lead agency to ensure that their departments are executing the intent of the NSM correctly. So that's one area that I think we're going to see that just playing out, just not even 2 weeks old. That will be a big thing that's going to be unfolding in the next few months.
Yeah, and the only thing I would add to that is you kind of alluded to it, Keith. I think it boils down to the lowest level where it gets implemented, right? The White House, the OSTP, all the guidance. We're supporting customs and immigration. I'm watching firsthand what's happening. They allow their employees, the 22,000 workforce, to use ChatGPT and other tools to do research. They will not allow them to use it in an unattended automation. This is a customer-facing, a citizen-facing entity, right? People coming in as new asylum, new refugees, et cetera. They are profoundly uncomfortable with allowing an unattended chat capability to interact. The bias, all sorts of issues are very real, and right now they haven't figured it out. We're trying to help them work through that. I will also point out that it also bleeds a little bit over into cybersecurity. The CISOs are very much involved with unattended automations and the use of these capabilities. So we could talk more about that, but in CIS in particular, if it's unattended and it has any flavor of bias, no, and the cybersecurity angles of that also come into play. So.
I do think that if there was going to be where we have I appreciate your viewpoints as well. The area where I think maybe the first area we're going to have more automated AI and Gen AI is going to be in cyber. IT cyber, where we, because the timeframes are so short to actually need to act, and we have the data. I think the AI capabilities are maturing so fast that they are able to act much more quickly and actually probably much more correctly in the timeframes needed in the cyber arena. So at least for defensive cyber, where we want to put in proactive or reactive defensive mechanisms, I think that's going to be much more automated, much more quickly than maybe some other areas.
And that's a perfect segue into our next question. So what emerging trends in data science or AI do you foresee having the most substantial impact on the US federal government in the next 3 to 5 years? And how might these impact government efficiency and, more importantly, public trust?
I was going to say a joke. Oh, I won't do it. I'm not going to do it. It's too close to the election. This is such an open-ended question. I don't know. I don't even know how to really think about this. Emerging trends in the next 3 to 5 years. So obviously, I think there's going to be a lot of work in cyber because that's just it's the data is there. It's the cyber analysts have a hard time even right now figuring out how to really process and triage all the information. So I see a lot of work in the cyber area, a lot more automated. Obviously, there's a lot of money in AI going into that space right now, but we haven't really put the frameworks in to really do that in a comprehensive way. So I think that's coming. I think there's going to be. So I think that we're going to grow both ways. We're going to continue to see growth in model size and in GPU requirements for AI, particularly Gen AI. I think we're not done. We're going to continue to see that, and so AWS, we're investing a lot of money in continuing to put GPU capacity into our regions. We do have commercial regions. We have GovCloud regions, which are for kind of host government unclassified government workloads. We also have a secret region to host secret data, and we also have top secret regions for mostly for the intelligence community. And so we're putting in GPU capacity across all those regions because all those customers we know they're going to need that. That's going to continue to grow. I also do see a shrinking of the models as well to make them more deployable. I think that's going to be a big focus area. How do I get whether it's Claude 3.5 or ChatGPT 04 or 4.0, quality in smaller sizes that we can deploy on edge devices, or at least on much lower compute capable hardware. I think that's going to be continuing to improve. I mean, just think of Apple. They're wanting to push this because they want to get more of the compute on their devices. So there's going to be some commercial trends they're going to be pushing in there. There's definitely going to be a nexus, I think, between AI and quantum. That might be 4 or 5 years away, but it's coming. And it's coming because obviously the payoff is so huge. But once we get there, that's gonna be I think that's probably the next game changer. Once they get that out, once we get to the qubit sizes of 1,000 to 10,000, we'll see new frameworks for how do I use Gen AI or advanced large language models or large scale models with quantum qubit analysis as well. And that's going to be an interesting area that there's current research going in right now. And the last one is more, I do think there's going to be more work in the frameworks, trustworthiness of the outputs, governance frameworks. There's going to be a continuing evolution. Just the NSM is just a start. I think that there's going to be a lot more work and money that's going in that because of the potential payoff if we get it right. That might require some new mathematical kind of proof models to be used or employed in the production workloads, and just understanding how to get our arms around trustworthiness. Is going to be an area that's going to continue to grow as well. I can go on, but I'll let my colleagues also provide some thoughts.
Yeah, so I'll pull the thread a little bit on compute. I don't remember the exact specifics, but if you look at the total power required to actually build the ChatGPT model, it was enough power to light everything in New York City for at a tremendous amount of time. I forgot what the actual number is, but it's crazy. And you just heard Keith say, right, that they're adding, within AWS, they're adding more GPUs and more compute. Frankly, that isn't sustainable, right? So I think one of the things that we'll see in the future is how do we actually build these models more effectively, more efficiently. I think moving towards some kind of quantum element is part of the answer there. I'm not 100% sure. Organizations like DARPA are actually trying to figure out different methods so that we can advance the state of the art there to make it more efficient, more power effective to build some of these large models. Because I mean, let's be clear, we're moving in that direction. We're going to continue to move in that direction. We just need to find a way to do it more cost effectively.
So I just had two kind of different from the way you get to approach this question. I think the question originally was government efficiency and public trust, and I looked at it more from an application layer almost. So two things that came to mind for me is agentic AI. So these are AI agents that have more agency than normal. They are increasingly more focused on a particular domain as opposed to a ChatGPT broad. The agentic AI capabilities will take over or provide efficiencies, I should say, in financial transactions and contracts and different things that you normally break down in a business or an organization. I think that's got potential to be mostly positive. It certainly has some Orwellian sort of underpinnings to it, which is displacing folks who may be very good at what they do. So it holds potential, and we'll see what it does for government efficiencies, et cetera. The other area that I thought 3 to 5 years, I think adversarial AI is something that I'm very concerned with. As we employ more AI ourselves, other folks are understanding what we are doing with AI and are have the potential to be querying and using prompts to effectively find out breakpoints and decisions and how things are implemented. I mean, AI against AI can start to look at how it was built and what it's designed to do, and I think that just is going to continue. And the more we depend on AI for ourselves, the more open that attack surface becomes, if you will. So that one's a little scarier.
I do think there's going to be another breakthrough on the underlying framework for how we think of neural networks. I think we're seeing this kind of play out. We see the positives, we see the negatives. I think there's going to be some additional innovations around kind of moving beyond the simple neural network approach to something that gives us a little bit more of the intuition pieces that we're currently missing in the neural networks. There's a lot of research going on in that area too, so I'm excited. I think there'll be something popping out in the next few years. Thank you all for those really incredible insights on AI in the DoD space. Unfortunately, we're at time for this panel discussion. I know it flew by. So we really appreciate you all, your contributions to this. If anyone in the audience has questions, please feel free to come up and approach our panelists during the next breaks. I'm sure they'll be more than happy to answer any questions you may have. But that's it for our panel today. Thank you all so much. We hope you enjoy the rest of the conference.
Thank you.
Thanks.
Thanks, everybody.